In this video, I want to show you what is the average value of a function. The definition is if a function is integrable on the closed interval ab, then the average value of this function f on this interval is given by the definite integral from a to b of this function and divided by this number b minus a. I will show you now. This is a continuous version of the definition. So I will first show you what is the discrete version of this definition. So to see the discrete case, let's consider this function. Fx equals 2 sine x plus x. Now, the average value of this function, if we consider the discrete case, say it will be equal to the summation of fxi, where I from 1 to 2 divided by 2. So what does this mean? This means we add the function value at x1 and the function value at x2, and then we divide by 2. So this will give us the average value of the function. So now if we increase the value of n into 4, so now we have the numerator, we have 4 function values, and the denominator we divide by 4. So this is like how the teachers figure out what is the average score of a class. So the teacher just add the grade of every student and then divide by the number of students who are taking the test. Right. So if we increase the n to 20, so the numerator are the sum of 20 function values, and then after we figure out what that sum is, and we divide by 20. So on the graph, we divide we divide this interval into into 20 even pieces. Okay. So let's say if we divide the interval into n even pieces, so this a is x1, and the next point is x2, and x3, and the last point b, and let be xn. So at each point we can find a function value, and we add them together and we divide by n. So this will give us the average value. Okay, and now I multiply this result by b minus a over b minus a. Because b minus a over b minus a, this equals 1. So actually, I didn't change the value by multiplying this term. And the next, if I switch these two terms, I switch n with the b minus a, so I can rewrite this into 1 over b minus a times the summation of this and times b minus a over m. Okay, then if I distribute this term b minus a over m into this summation, I will get this. Now, if we consider we have infinitely, if we divide this interval into infinitely many pieces, that is equivalent to have n approaches infinity. So when I have m approaches infinity, I take the limit. I want to take the limit of this term as n approaching infinity. So this, what we have in the bracket, will be a Riemann sum. Now in this Riemann sum, b minus a over n is our delta x. And in the previous lecture, we said the limit of this Riemann sum, we can use this symbol, the integral from a to b fx dx, to represent. So that's why the average value of the function equals this definite integral multiplied by 1 over b minus a. Okay. So what does this mean on the graph is since this average value equals 1 over b minus a times this integral. So in other words, the product between this average value and b minus a equals this definite integral. So this result tells us we can find a number on the y-axis, and that number equals this average value. For example, it could be here. Okay. So, and then this equation tells us the area of the region bounded by this curve is equal to the area of a rectangle. Now this rectangle has the length equals b minus a. So the length is b minus a, and the height equals this average value. So the area of this bounded region and the area of this rectangle, they are the same. They are the same. Okay. Okay. Let's take a look at this example. We want to find the average value of the function fx equals sine x on the interval from 0 to pi over 4. So according to the definition of the average value, here the function a is a sine of x, and a equals 0 and b equals pi over 4. So the average value is 1 over pi over 4 minus 0 times the integral from 0 to pi over 4 sine x dx. Okay. So we first want to figure out what is this definite integral. We can do this by using the first fundamental theorem of calculus, because the antiderivative of sine x is a negative cosine x, because the derivative of negative cosine x is equal to positive sine x. So we have a negative, so 1 over pi over 4 times negative cosine x, where x from 0 to pi over 4. And 1 over pi over 4 we can write as 4 over pi times negative cosine x from 0 to pi over 4. So this equals negative cosine pi over 4 minus negative cosine of 0. Cosine pi over 4, that is the square root of 2 over 2. So this is minus square root of 2 over 2. And cosine 0 equals 1. So this is minus negative 1. This is 4 over pi times negative square root of 2 over 2 plus 1. So the average value of the functions f(x) equals sine x on the interval from 0 to pi over 4 equals this.